welcome to this channel. Uh, Good morning, good afternoon, good evening, wherever you find yourself across the globe. We are looking at the complex number two, the part two. We started the complex number yesterday. We're looking at another aspect in complex number. We'll be looking at the Argand diagram, uh, modulus of a complex number, arguments of a complex number, and finding the square root of a complex number. The meaning of that. Argand diagram is a representation of a complex number, okay, on a Cartesian plane, whereby the real part of the complex number will be on the what? X-axis. The imaginary part of the complex number will be on the vertical axis of the Cartesian plane. Okay, so let's see example for that. Let's say you have complex number z1, okay, possibly 2 plus 5i. You have another one, z2, equal to possibly minus 2, minus 2 plus 7i. You have another complex number, z3, possibly you have minus 4 plus 8. Let's make it minus 8i. Okay, so these are the complex numbers that you have, and you want to represent this on the complex, on the Cartesian plane. Okay, you want to draw the Argand diagram. So what you do is to sketch your x and y axis. Okay, sketch that. This is your y axis. This is your x axis. Okay, let's sketch the one of z1. Z1 is 2 plus 5i. The 2 is the real part, which will be on the horizontal axis. The imaginary part is the 5i. Okay, and that will be on the what? On the vertical axis. The coefficient of that I will be on the vertical axis. So let's represent that on the complex number. Okay, I'm going to make just a sketch. It's not a perfect diagram. So this is your origin. Okay, when you have 2, this is 1, this is 2. When you have 2, the y is what? Is 5. 1, 2, 3, 4, 5. Then you move up like that. Okay, and then you indicate that point. Then you go for the origin, and you go for the origin. This will go. When it's at 2, you have a y as 5. Then you connect on the origin the points. Connect from the origin the point, and then you indicate the point. Let's call that z1 as a point 1. Put the coefficient, the real part, that's 2. The imaginary part. The imaginary part is the coefficient of I, and then you put 5 there. So complex number z1 is having what? 2,5, and we have done that. Okay. Then another one, z2, we have minus 2, 1, minus 1, minus 2, minus 3, minus 4, minus 5. Okay. So you indicate this is a minus 2 when x is minus 2. Okay. You have what? You have 7 on the 1, 2, 3, 4, 5, 6, 7. So just go there, indicate that, then you indicate the points. Then from the origin, you what? Okay, so that's the point B. Let's call it point B, and that will minus 2, 7. That's minus 2, 7. That's minus 2, 7 for that place. And let me quickly say something. The Argand diagram is always of this form, x plus y I. Okay, where your x is the real part, which will be on the vertical x-axis, to be on the horizontal. The coefficient of your height will be on the vertical line. Okay, so that is the general representation of the Argand diagram. The last one, z3 is equal to minus 4 comma 8. So that means x is what? Let's indicate this one. Minus 1, minus 2, minus 3, minus 4, minus 5. So when we have x as minus 4, then we have y as what? As 8. 1, 2, 3, 4, 5, 6, 7, 8. Then you go there, indicate the points, draw the straight line, and then you connect it from the origin and get your and draw your Argand diagram. So this is a point C for the Z3. So then minus 4 comma 8. So that's just the sketch of the Argand diagrams. Okay. So when we go to modulus, this line here from the origin, okay, that is the modulus. But when we get to modulus, I will explain that. So that's that on the Argand diagrams. As you are coming in, just begin to say ah. As you are coming in, just begin to say ah. If you are yet to subscribe, please do that right now. Begin to share the links of this video across your social media platform. Call your friends to join us for this live section. Call your classmates, call your friends, your classmates to join us for this live section. Begin to like, share, and subscribe. Like, share, and subscribe. The modulus of a complex number. The modulus of a complex number. Modulus of a complex number. Imagine you have a complex number z equal to a plus bi. Let's imagine that's your complex number. A is the real part. The one that has the I is the imaginary part. This is the real part. This is the imaginary part. Okay, the one with the I is the imaginary part. Okay, so how do we get your modulus? Modulus has this symbol. That's this symbol, or use R for the modulus. Okay, and if you want to get the modulus of this, we just put a slash across the complex number. So that one means complex. It means modulus. By the time you put a line, okay, front, back, that's the modulus of this complex number. And for z, the modulus of z is this. That's a symbol. That you use this one, or you use R for modulus. And how do you get the modulus? Modulus is very simple. Is equal to what? Square root, the real part, you square that. The coefficient of your I, that's a b, you square that also. That is what we call the modulus. Okay, then you can also get what we call the argument. Okay, you can get the argument of a complex number. I'm going to do this one in two ways. This way, and using Pythagoras theorem to get your modulus. Okay, and using what do you call it, tangent, to get your argument of a complex number. Okay, if you want to get the modulus, the argument of a complex number, argument of a complex number, it has the symbol arg. And if the complex number is okay, let's need this one. Let's need the modulus. So if you have z equal to 4 plus 5i, and you want to find the modulus of that complex number, that will be equal to what? 4 square, the real part, and then the imaginary part, the coefficient of your I, that's a 5 square, and that will give you 16 plus 25. Okay, and that's a root 41 for the modulus of a complex number. And at the same time, you can also make a sketch. Okay, you can make a sketch of using your Argand diagram to sketch the complex number, and from there use the Pythagoras theorem to get the modulus. So let's look at that. Find the modulus. Let's imagine you want to find the modulus of this 4 plus 5i. I want to use Pythagoras theorem. We're going to sketch the we're going to sketch it on the what do you call it, the x and y coordinates. Sketch that on the x and y coordinates. This is your origin. Okay, the 4 is the real part, which will be on the horizontal. So 1, 2, 3, 4. So 4 is here. Okay, then you go up and indicate the 5. 1, 2, 3, 4, 5. Indicate the 5 there. So we have this. That's 5. Okay, and then you connect that from the origin. You close it from the origin. So this is you can call it maybe point A. That's a 4,5. So this line, the line from the origin, is called the modulus, which we can use R to represent the modulus, or you can use Z with this slash, okay, to represent the modulus. So from here to here is your 4, and then from here to here is your 5. So this form a right angle triangle. Then we can use Pythagoras theorem to solve it. So Z, okay, is equal to that will be equal to the Z is that will be equal to square root this one 4 square plus what 5 square. Okay, Pythagoras theorem says that the square of the hypotenuse, the square of your hypotenuse, the square of the hypotenuse is equal to what? Square of the sum of the square of the other two sides of the triangle, 4 square plus 5 square. Then you can remove these two from here by taking the square root of both sides. So if you do that, you're going to have this, okay, equal to what? Square root of what? 4 square plus what? 5 square. So that's that on the modulus of a complex number. Then we can quickly go to what we call the argument of a complex number. We can go to the argument of a complex number. Argument of a complex number. Okay. Argument of a complex number. Okay, the symbol, well, we call it Z. Okay, Z or Z. That's the symbol for argument of a complex number. And we use tan theta. We use tan theta, okay, to get the argument of a complex number. And that is there from here. This is you can put the theta here. Okay, that's the theta, which is equal to opposite over what? Over adjacent. Then you can find the theta. So your theta is what? Is arctan 5/4. That is the what do you call it? The argument of that complex number. That's the argument of that complex number. We're going to play with these for more clarification. That's the argument of a complex number. And if you are not if you are not checking, if you are not sketching at all, okay, argument is what? Your argument is tan theta equal to what? The vertical axis over the horizontal axis, and then you can find the theta, and that will be what? That will be arctan y over x. So that's that on that. Now the first question: find two decimal places, a modulus and argument of z equal to 2 plus 7i. That's the first one. The second one also, find two decimal places, the modulus and arguments, and that should be in radian of z equal to -5 plus 2i. Okay, we can use the Cartesian coordinate to make a sketch, but it's not a must to do that. The first one, we have z equal to 2 plus 7i. That's what we have there. Okay, let's sketch our Cartesian coordinates, the x and y axis. Okay, just a sketch. It's not a perfect diagram, just a sketch. Uh, on the horizontal, we have 2. We have 2. This is the origin. So we have 2. And then from 2, we have 7. Just pick any value on the vertical for your 7. Pick any value on the vertical for the 7. I'm going to stop here. This is 7. And from here to here is my what? Is my 2. Then from the origin, we are going to connect the points together. Okay, so I can just indicate this one as 2,7. X is 2, y is 7. And this place is your modulus. That is your modulus. That is your modulus. Indicate the y axis, indicate the x axis. Okay, so that will be equal to the modulus is this, or we use r for that, and that will be equal to, use your Pythagorean theorem, this square plus this square equal to what? R square. And then you take the square root of both sides, and that will be equal to what? 2 square plus what? Plus 7 square. Or let me make it r equal to x square plus y square. Okay, then we get that, and that will be equal to 4 plus 49, and that's square root of 53 if you add the value together. So that's that on that. Then the arguments which has a symbol z. Z is equal to, without wasting our time, this is a theta. This is theta. You go counterclockwise. This is a theta. Okay, that's theta. We use tan theta for arguments, which is the vertical over the what? Horizontal. And theta is equal to what? Arctan. Your vertical is what? 7. Your horizontal is 2. Okay, then theta will be equal to arctan. We are told that the value must be in radian. Just put your functions in your calculator in radians and get the value of this. Okay, let's check the calculator. As you are coming in, just begin to say I. As you are coming in, just begin to say I. As you are coming in, just begin to say, thank you, my friend. I'm very good. I'm very good. Hydrogen. It's been a while. Thank you. Thank you. Thank you. Begin to please call someone to join you also. Call someone to join you. Okay. I want to also need people also. Call someone to join you. Invite your friends. Share the links, hydrogen, to your friends, your classmates. And thank you for doing that. Let's press our calculator. Punch your calculator for that. That will be 1.29. That will be 1.29. That's 1.29 in radian. 1.29 rad. Okay, that's 1.29 in radian, and 2 decimal places that's been done. So that's the first one. That's the first one. Begin to share the links across your different platforms. Call someone now. Call your friends, your classmates to join us. Okay, that is one of the ways to support this channel. Go beyond just watching or looking. Okay, this is not a movie. Share the links across your different platforms. Please take your journal, your writing material, your pen, and begin to follow along with me. Hydrogen, have you started question 2? If you have not, you can do that right now as you used to do. Okay, welcome, my friend. Welcome. We're going to share the links. Call your friends to join us for this live section. Very good. How are you also? How is India over there? You're welcome. The question 2, we have this. I'm going to do it here. Question 2, we have this. Draw your Cartesian plane, but it's not a must. You can skip that and just do it straight away. Okay, this is the origin. Okay, we have -5. -5 will be on the negative x-axis. The real part is on the horizontal. The imaginary part, the attachment to your eye, will be on the vertical as is. Okay, so this is a -1, -2, -3, -4, -5. Okay, and then you go up. Okay, I can make this one just, I can stop anywhere. So it's just a sketch. Okay, this is my 2 on the vertical. Then you connect that from the origin. You connect the points. You connect the points from the origin. You connect the points from the origin. So we can call this one maybe B, point B, which is what? -5 for X and 2 for Y. Okay. Oh, sorry. -5 will go down. Sorry for that. -5 would go down. This is the origin. So -5, yeah, you just move down. Okay. Let's stop here for my 2. Let's stop there. Then you connect that from the origin. You connect the points from the origin. So this is your modulus. This is from here to here is 5. You don't need to put minus there again because we know that that position is the negative side. Okay, -5. What is wrong? When it's 5, I'm already correct now. When it's 5, you go up. Your y is at 2, so it go up. Okay, you go up. When it's 5, you go up. You go up. So that's 2. Let's call it point C. That's -5, comma 2. Okay, then you connect the points to the origin. So this is your modulus. This is your modulus. Okay, and the theta will be here. You move counterclockwise. Okay, so this will be your reference angle, which you can call the alpha. That's your reference angle. Okay, let's get the modulus first, then I will now begin to talk more on the arguments. The modulus will be equal to what? Will be this x squared plus y squared. You can skip this diagram, but it's very good for you to sketch the diagram so as to know which quadrants the complex number falls into. So this will be equal to my x is what? That's a square root of what? -5. Okay, use the Pythagorean theorem. That's a 5 square plus what? Plus this one is a 2 plus a 2 square. Okay, that's a root 29 for the modulus. Root 29 for the modulus. Okay, 29 for the modulus. Okay, but to get the arguments at z, let's get the theta first. Don't make a conclusion. Theta, that will be 10, 10. Let me call it theta. Let me call this place theta. 10 theta is equal to, okay, the reference angle. The reference angle. Let's call this one from here. Okay. Possibly you call it. Can call it. Let's call this one maybe alpha. Alpha. And this place the reference angle theta here. Okay. So tan theta is opposite over what? Over opposite over adjacent. Then you get the theta. That will be arctan 2/5. Then check your calculator and make it in radian. 2/5. Check your calculator and make it in radians. That's 0.3805 rad in radian. 0.3805. Okay, let's call this one. This is make it want to be alpha. Okay, then this is alpha. This is alpha, and alpha, but I'll call that. That's that. Okay, That's that. And this angle falls in the what? It falls in second quadrants. This fall in the regions of second quadrants. Don't forget your quadrants. This is a first quadrant. Okay. Uh, this is a second quadrant. This is the third quadrant, and this is the fourth quadrant. So when you fall here, when your value fall here, okay, if your value fall here, the reference angle will be what? For second quadrant is 180 minus what? Minus theta. Whatever you have here, okay. In that case, we call it alpha. So that would be 180 minus what? Minus alpha, and that will give you the reference angle. Okay. You can stop here, but to get the full mark, get the reference angle because it's angle on the straight line. Okay. So that's the first second quadrant. Okay. That's second quadrant. That is the second quadrant. Okay. So that will be equal to, the answer will be equal to, in second quadrant, that will be pi, which is 180 minus 0.3805. Okay, we're working in radians. And you can make your substitution, your calculator, and punch the answer. Okay, that will be 2.76 radian. 2.76 radian. Okay, and that was 2.76 radian, 2 decimal places. 2. That's the equivalent of that answer. Okay, that's the what do you call it? Reference angle. Okay, of this. Yep. So that's that on this case. Questions still continue. For those that are just coming in, begin to say "I." You are welcome once again. We are looking at the complex number. Okay, we've explained Argand diagrams. We've explained modulus and arguments. Then the next one to do now is just take more questions, and then we'll now go to what? We'll go to another aspect, and that'll be finding a square root of a complex number. Finding square root of a complex number. Then after that, we begin to take a series of questions on complex number. Okay, we can't finish the complex number today. We are still going to continue and have the part 3, part 4. Okay, so stay by. Watch to the end of this program to get the maximum comprehension. If you're yet to subscribe, please do that right now. Like, share, and subscribe. Like, share, and subscribe. Call your friend now to join us for these segments. Yeah, the question we have here, we have find two decimal places, the modulus and the arguments, okay, of z equal to -4 minus I. Okay, to find the what do you call it, the modulus. Okay, you can use this one, or you can use R. Okay, you can use this, or you can use R. The choice is yours, which will be equal to what? -4 minus R, and that will be equal to square root of -4 squared plus what? Plus -1 squared. Okay, and that will give you 16 plus 1. That's root 17. Okay, but it's more better to sketch so I can get the accurate modulus arguments of the complex number. So let's make a sketch of, so I can know the quadrants in which the complex number falls. Okay, this is your y, this is your x-axis. We have the this is your origin. We have -4 on the horizontal. So 1, 2, 3, 4. -4 on horizontal, and then -1 on the on the negative y. So take it down. Okay, so let's call it this is a -1, and then from the origin you connect the points. You connect the points. So let's call it A. That's equal to what? -4, -1. That's the point A. So call this one here your alpha. Okay, and then you can see what we have here. We are what we have here. Let's move. Uh we are moving anti-clockwise. Okay, okay. The up is counter-clockwise. When you are moving down like this, we're moving uh, anti-clockwise. Okay, so that's that on this case. Let's get the alpha, then we can get the argument time. Alpha is equal to opposite of the angle from here to here. That's what that's y, that's 1, and then from here to here, that's 4. So that's 1 over 4. That's 1 over 4, and then this will be equal to what? Arctan 1 over 4. Okay, then we can get the argument, which is arg z equal to. You can see what we have here. It's still angle on a straight line, but this one is down. It's not up, it's down. Okay, so look at where we are moving. Okay, so you're going to be, because it's not up, you introduce minus, and then you close it. Okay, angle on a straight line is what? Pi minus what? Arctan what? Arctan 1 over 4. Okay, so that's that. Because it's below the surface and you're moving anti-clockwise, okay, or anti-clockwise, you're moving, that's your direction, that makes it to be negative, okay, and angle on the straight line is 180, and that will be pi minus what? Minus your alpha, which is what? Arctan 1 over 4. And then just put this in your calculator and get the answer. And that is the essence of making a sketch, so you can have idea of your which quadrant it falls. So this falls in third quadrant. Okay, the complex number falls in what? Z is in Q3, third quadrant. Okay, that's in third quadrant. That's in third quadrant. That's in third quadrant. Okay, that's very good when you can sketch it. You know the quadrant, the complex number falls, and you can easily make the correct conclusion for your Z, for your arguments. Okay, so that's that on that. The one we did before is in second quadrant, and you see angle on a straight line. That one is positive, and that one is pi minus alpha. But in this case, it's below, making it to be what? Minus, and then angle on a straight line, that's 180 minus your alpha. So that's that on this case. We want to take a question for now, and after that, we look at finding square root of a complex number. Finding square root of a complex number. Okay. Let's look at the question. Let's look at the question. So we're looking at problem solving. Involving complex number. Yeah. Problem solving involving complex number. Okay, given that 3 plus 5i equal to a plus ib. Okay, the bracket close, and then 1 plus I, where a and b are real. Find the values of a and the values of b. Okay, I think this one is under equality of a complex number. Okay, when two complex numbers are equal. So that's that on that. So what we do in this aspect is for us to do the expansion of the right hand side. Okay, do the expansion, do multiplications of two complex number. Okay, and after you have done that, then you now begin to equate the real part together, form an equation for the real part, and then form an equation for the imaginary part. Equate the what? The real part together, equate the what? The imaginary part together. And by the time you do that, you form two equations, and then you solve it, algebraically. Okay, you are just coming in, please, you are in the right place. I want to say you are in the right place. Okay, begin to share, like, share, and subscribe. Don't watch alone. Call your friend, your classmate to join us, and begin to share the links across your different platform. Okay, begin to share the links across your different platform. Okay, subscribe straight away. Let's go straight to the action. We have uh, the uh, the right hand side. The right hand side, we have a plus I times b, and then times 1 plus I. So do the expansion. That'll be a times 1. That's a. And then a times I. That's what? That's a I. Okay. And then plus this one, IB times 1. We have BI. Okay. And finally, I B times I. So it's going to give us I squared times what? Times B. Okay. And note that your I squared is minus 1. Note that your I squared is minus 1. And that will be equal to A minus B. Okay. And then plus. I'm going to factorize the complex number there. I is common, and I'm having A plus B in that place. Okay. A plus B in that case. Then I can now begin to equate the left hand side with the right hand side. Begin to equate your right hand side with your left hand side with your right hand side. A minus B plus A plus B I. Okay, equate the real parts. Equate your real parts. Equate your real parts. So if you do that, you're going to have, this is the real part. You want to have no I. That's the real part. And that will be A minus B equal to 5. Can you call it equation 1? Okay. Then equate the imaginary parts. Equate your imaginary parts. Equate your imaginary parts. That's the attachment of your complex number of your I. Okay, which is what? Which is A plus B. Okay, here also, please open these brackets. There's no need to close it again. Open the brackets, equate the imaginary part. Here is A plus B. The attachment to your I. Okay, equate them together. So A plus B equal to what? Equal to 5. The real part, A minus B, is equal to what? Is equal to 3. Okay, call this one equation 2. Let me quickly recap what we have done so far. Okay, but before I do that, if you're just coming in, I want to say you are welcome. Okay, and you are in the right place. Begin to share the links of this video across your different platforms. Begin to do it right now. If you're yet to subscribe, please do so right now. It's very crucial for this channel. Okay, please do so right now. That is one of the ways to support this channel. Begin to share the links across your different platforms. Okay, don't watch alone. Call your friends, call your classmates to join us for this section. Okay, what we are looking at is this question. Okay, we call it equality of complex number. We have this question. Okay, what we are going to do is for you to expand the complex number, do the expansion, do the multiplication of the two complex number, which we have done here, which is this one times this one. We have A, this one times the last one. We have AI, and then IB times 1. We have this, and finally this times this. We have that. This times this. We have that. Okay, and then I squared minus 1. Okay, and then that gives us this. And then begin to equate the complex number. Begin to equate the complex number. The real part is A minus B. Okay, on this side. The real part also here is what? 3. That is equate the real part. The imaginary part, that's the attachment to your I. Equate that on the two sides of the equation. Okay, and that will be A plus B equal to what? Equal to 5. So that's what we have gotten in this case. Okay, let's quickly check the comment and come back again. So we have these two equations. We have these two equations: a minus b, a plus b. This is a 3. This is a 5. Can you add them together? Add the two equations together. That would be 2a equal to what? Equal to 8. So a is what? A is a 4. A is 4. Okay? And you can substitute, make a substitution to any of the equation. Okay? Make a substitution to any of the equation. Let's use a minus b. A minus b equal to 3. My a is a 4. Okay? And that will be equal to what? Move this minus b to the other side. And that will be what? 4 minus 3 equal to what? Equal to b. So b is equal to what? B is equal to 1. B is 1. So that's that on that. Then you can make a statement that a is 4 and b is 1. So that is the end of that question. And that will now take us to how to find square roots of a complex number. How do we do that? How do we find square roots of a complex number? And this is very simple answer. Okay, what you need to do is to follow a procedure. It's a procedure. It's not a single answer. You need to follow the procedure of how to find square roots of a complex number. You need to follow the step by step of how to find the square root of a complex number. Okay, begin to share the links of this video. Share. Okay, like, share, and subscribe. Like. Yeah, what we're going to do in this case, solution, find the square root of 3 plus 4i. So we're going to say, let the square root of that complex number, let it be equal to a plus bi. Make it another complex number. The real part, the imaginary part. The square root, okay, equal to this. Then you square both sides. Square both sides of the equation. Square both sides. So if you do that, the square root will go. We have 3 plus what? 4i equal to what? A plus this square. And then you can do the expansion of this one, which will be a square plus 2abi, and then plus the last one, that's a b square I square. Okay, that's that on that case. Okay, you can use normal expansion. I've done this so many times. Use normal expansion, you still get the same answer. Okay, and that will be equal to a square. Okay, plus this one, I square is minus 1. So that will be a square minus b square plus what? 2abi. That's what? 3 plus 4i. Okay, then equate the real parts. The real parts, equate your real parts, which is a square minus b square equal to 3. Call it equation 1. Equate the imaginary parts, which is what? 2ab equal to 4. Okay, the coefficient of your I. Equate them together. So from here, ab is equal to what? Is equal to 2. If you divide both sides by 2, then you can make b as the subject. Make b as the subject and call this one equation 2. Okay. Then begin to substitute. Substitute into a square minus b square equal to 3. Let's do that. That will be a square minus my b is what? If you square this one, we're going to have 4 over a square equal to 3. And then multiply this by a square, this by a square, this by a square, just to cancel the fraction. And that will be a4 minus a 4 equal to what? 3a square. Okay, then bring everything to one side. That will be a to the power 4 minus 3a squared minus 4 is equal to 0. And then we can factorize the expression. A squared is there. Begin to pair that. A squared, and then the factors of 4. Okay, they can generate minus 3. That will be minus 4 plus 1. Minus 4 plus 1. Okay, and this implies a squared is equal to 4, or a squared plus 1 is equal to 1. So a is equal to plus or minus 2. That's one. The other one, a plus 1 is equal to 0. A plus 1 is equal to 0, which is a is equal to that will be plus or minus I. Plus or minus I. Okay, plus or minus I. So I'm going to take one of them. Okay, if A is a plus, if A is a plus or minus 2, then B will be equal to what? Where's your B? The B will be equal to 2 over A, which is a plus or minus 2. And that's plus or minus what? 1. Okay, so A comma B is equal to what? A comma B is equal to, my A is what? Plus or minus 2. My B is what? Plus or minus what? 1. Okay, then we can go back to, we say let the square root of this be this. Let the square root of this be this. So once we get A and B, this will be your answer. Okay, so that will be equal to A plus BI is equal to, my A is what? My A is a plus or minus 2 plus, my B is what? Plus or minus 1. Okay, then I can take the plus or minus out, and that will be 2 plus 1. 2 plus this one is a 1i. Okay, B is a 1. So 1i. So that's 2 plus I. Okay, 2 plus I. So that's my answer for that. And if you use the other value, you're going to get the same answer also. So that's been confirmed. If you make substitution for the second one, you're going to get the same value. Okay, then you now say the square root, the square root of 3 plus 4i is what? Is this. Is this. Okay, and that's fetch you a full mark. That fetch you a full mark. That gets you a full mark. Begin to say I as you are coming in. Like, share, subscribe. Okay, call your friends to join us. Questions still continue. Call your friends to join us. So that's that on these aspects. 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 Okay. Thank you, my friends. Thank you. Appreciate your commitment to this channel. Thank you. Begin to send your question. Forward your questions. Okay. Forward your questions. Forward your questions. Okay. Forward your questions. I'm going to give. We are going to take general questions. Okay, let's begin to take general questions on what we have done so far. Questions on what we've done so far. Let's do questions, solving questions now. Complex number. Solving questions on complex number. Okay. We have given that Z1 is 1 plus I, Z2 is 2 plus I, Z3 is 3 plus I. Find answers for 1, Z1 times Z2 over Z3. Likewise, our second one, Z2 squared over Z1, and then 2Z1 plus 5Z3 over Z2. Let's go straight to the solution for this question. The first one, let's get the Z1 and Z2, okay, which is a product. Our Z1 is this one. Our Z2 is 2 plus I. Okay, do the expansion. That will be this one, 1 times 2, that's 2. This one times this one, that's a plus I. And then I times 2, that's a plus 2I. And finally, I times I, that's minus, that's a plus I squared. Okay, so that's giving us 2. This will be minus 1. This one and this one, that's a plus 3I, which is a 1, okay, plus 3I. Okay, that's the sum. Let's now do the Z1, Z2 over Z3, which will be 1 plus 3I over my Z3 is 3 plus I, and that's now form division of complex number, divisions of two complex number, which we have done before. Okay, and when you have division of two complex number, what you do is to get the conjugate of the denominator, get the conjugate of the denominator and use it to multiply the top, use it to multiply the bottom. The conjugate of the denominator is what? Is 3 minus I, okay, times 3 minus I. So that's that on the conjugate. Conjugate is just that you go to the expression and change and alter the sign that connect the real parts and the imaginary parts. Okay, if it's minus, to change to negative. If it's negative, to change to plus. So use the conjugate to multiply the top and the bottom. Okay, and that's that on that. And what we want to achieve is to ensure that at the end of the day, there is no imaginary part at the denominator. There's no imaginary part at the denominator. So let's do the expansion. Let's do the expansion. 1 times 3, that's a 3. 1 times I, that's a minus I. Okay, 3I times plus 3I times 3, that's a plus 9I. And then plus times minus, that's a minus, that's minus. And then 3I times I, that's a 3I squared over. Whenever you have the same expression but alternating sign, okay, same expression, alternating sign, we call it difference of two squared. And you don't have to waste your energy. Just for you to take the first one, square that, minus, and then the second one, square that, square that. That's what we call the difference of two squared. Okay. Note that a minus b times a plus b is equal to is a vice versa. That will be a squared minus b squared. So if you have something like this, you can turn it to this one, and also you can also turn this one to this one. It must be the same expression for alternating sign. Same expression for alternating sign. So that's that on that case. That's that on that case. For the denominator, that will be equal to 9. This will be minus 1. So minus into bracket minus 1, and that's a 10 for the denominator. That's a 10 for the denominator. And then for the numerator, we are going to have so this will be equal to, for the numerator, we have Z1, Z2 over what? Over Z3 will be equal to, this will be equal to, it will be equal to 3. This one, I square, is minus 1, okay? And that will give us plus what? Plus 3, okay? This one and this one, combine them together. And then minus I plus 9I. Just add the attachments. -1 plus 9, that's a plus 8 I over what? Over 10. And that will give us 6 plus 8I over what? Over 10. Okay, and that implies 6 over 10 plus what? 8I over 10. 2 here, 3, 2 here, 3, 2 here, 5. That's a 3 over 5 plus what? 4 over 5. Okay, so that's the real part and imaginary part. And if you don't want to do it this way, you can as well take 2 outside, and that will be what? 3 plus 4 over what? 2 times 5. So this one and this one we cancel. Then you have 3 plus 4I over what? Over 5. So that's that on the first one. That's that on the first one. I'll take just one more. You also do the B part. That will be your quiz. Let's see your response for the second one. Okay, put the answer of z squared, z2 squared over z1. Begin to do that and put the answer in the comment section. I don't know the answer, okay, but when you solve it, I'll also do the same thing also. Do that and put the answer in the comment section. Okay, so that's that on that. Let's see response for this. Let's see response for this for question 2. Let's see your response for that. Okay, let's see your response for that for question 2. Let's see your response for that. Let's see your response for that. So for the third one, 2, that will be 2z1 plus 5z3 over what? Z2. That will be what? 2 times z1 plus 5 times z3 over z2. Okay, and that will be equal to that will be equal to 2, this one times this one, this one times this one, plus 2I, and then plus 5 times 3, that's 15, plus 5I, all over what? All over 2 plus I. Okay, all over 2 plus I. So that's what we have in that case. Okay, that's what we have in that case. That's what we have in that case. And that will be equal to 2 plus 15, that's 17, and then 2I plus 5I, that's 7I over 2 plus I. Okay. Begin to give the videos a thumbs up. Give the videos a thumbs up and share the links across your different platform. 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 Okay, share the links across your different platform. Share the links. So please finish this one up. Finish it up and let's see your response on the comment section. Let's see your response on the comment section. We're going to continue this next class. Finish this up and let's see your answer in the comment section. We're going to continue. Complex number still continue. Okay. Thank you for your time. See you next episode. It still continue. Part 3 will continue with the complex number. Thank you. Bye for now.